You're listening to the Cyberwire Network, powered by N2K.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform.
The word is Web Application Firewall. Spelled web, as in the internet, application, as in a software program, and firewall, as in a barrier between two networks that can limit network traffic between the two sides. Definition: a Layer 7 firewall designed to block threats at the application layer of the Open System Interconnection Model, the OSI model. Example sentence: with a Web Application Firewall, or WAF, firewall administrators can make rules like the marketing group can go to Facebook, but the sales group can't. Origin and context. In 1988, Jeff Mogul, Brian Reed, and Paul Vixie, working for Digital Equipment Corporation, conducted the first research on firewall technology. This was the first generation of firewall architecture. Between 1989 and 1990, Dave Presotto and Howard Trickey of Bell Laboratories pioneered the second generation with their research in circuit relays. They also implemented the first working model of the third generation firewall architectures known as application layer firewalls. Between 1990 and 1991, Gene Spafford of Purdue University, Bill Cheswick of Bell Labs, and Marcus Ranum independently researched application layer firewalls. These eventually evolved into next-generation firewalls many years later. In 1992, Digital Equipment Corporation shipped DEC Seal, the first commercial firewall, and included proxies developed by Marcus Ranum. In 1994, Checkpoint Software released the first stateful inspection commercial firewall, a Layer 3 firewall. Layer 3 refers to the OSI model, meaning that firewall administrators can make rules based on IP addresses, ports, and protocols. In 1994, William Cheswick and Steve Bellevin published Firewalls and Internet Security, Repelling the Wily Hacker, the first book on firewalls as a technology. They called it a circuit-level gateway and packet filtering technology. Interestingly, their ideas came from the desire not to keep intruders out of their networks, but to keep employees from going to bad places on the internet. Palo Alto Networks launched the first next-generation firewall in 2007, a firewall that not only does stateful inspection at Layer 3, but more importantly, allows rules at the application layer, Layer 7. Firewall administrators could not only block network traffic to and from bad IP addresses, but also could block access to applications tied to the authenticated user. By the 2010s, some firewalls had morphed into giant orchestration engines. In other words, instead of deploying multiple independent security tools in line at the perimeter that the InfoSec teams had to manage and orchestrate separately, the next generation firewall became a Swiss Army knife of security tools. One box, either hardware or software, that could do everything: Layer 3 policy, Layer 7 policy, intrusion detection, anti-malware, XDR, etc. By the late 2010s, the Secure Web Gateway emerged as a simpler firewall that abandoned the orchestration engine idea and just performed Layer 7 policy functions, but specifically for endpoint user web traffic. Firewall administrators can make rules for URL filtering, malicious code detection, and application controls for popular web-based applications, such as instant messaging and Skype. In contrast, web application firewalls can do most of the same things as secure web gateways, plus some basic heuristic and anomaly detection to prevent exploitation of application vulnerabilities. reference. In 2015, Bill Cheswick presented at the Vintage Computer Federation Conference and talked about some of the early days of computer security when he took a job at the famous Bell Labs in the 1980s and worked for some computer science legends like Dennis Ritchie, the co-creator of the C programming language and the Unix operating system written in C, with colleagues Ken Thompson, Brian Kernighan, and Rob Pike. And he talked about how his experiments with proto-firewalls protected Bell Labs from the infamous Morris worm in the late 1980s.
And in 1987, I said, I wonder if I could work at Bell Labs. Could I do this? I'm an IT guy. I could go be janitor for Dennis Ritchie. How cool would that be? And I applied, and the interview for the day involved 8 people, most of whom many of you have heard of: Brian Kernighan, Rob Pike, Ken Thompson, Dennis Ritchie, and a couple others, my future bosses. And I decided, even if at the end of the day they decided I was a jerk and they never wanted to see me again, it was a pretty remarkable day. And it turns out they hired me. I was working there for 3 weeks, and I said, well, I've started work. I volunteered to work as postmaster, which is kind of like volunteering to be proctologist. It's a thankless job because if you get it right, nobody notices. And if you don't, they're really pissed off with you. And I went up to the postmaster, Dave Prezzato, and I said, this email seems like a wave of the future. I want to learn something about it. I'll be postmaster. He said, okay, you got it. I also took over a prototype firewall he'd put up about a year before and started running it. About a year later, the Morris worm came out, and our firewall stopped it. In fact, I woke up the morning the Morris worm hit the internet, and a friend of ours had called the house and said, there's something bad on the internet. You might want to check it out. And I went into work, and there was Peter Weinberger on the phone calling various places and saying, did you get the worm? We didn't. Ha, 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 ha. And of course, it was my firewall that was keeping it out.
Word Notes is written by Tim Nodar, executive produced by Peter Kilpie, and edited by John Petrick and me, Rick Howard. The mix, sound design, and original music have all been crafted by the ridiculously talented Elliot Peltzman. Thanks for listening.
Now, a word from our sponsor, the Johns Hopkins University Information Security Institute, currently seeking qualified applicants for its innovative Master of Science in Security Informatics degree program. Study alongside world-class interdisciplinary experts and gain unparalleled educational, research, and professional experience in information security and assurance. Interested U.S. citizens should consider the National Science Foundation's CyberCore Scholarship for Service program, which covers tuition and a $6,000 annual professional development allowance, as well as providing a $37,000 additional annual stipend. Apply for the scholarship and the fall semester by March 1st. Learn more at cs.jhu.edu/MSSI.